Introduction to the Archean Eon. The Archean Eon, spanning from approximately 4.0 to 2.5 billion years ago, marks a crucial phase in Earth's geological history. It is characterized by significant geological, chemical, and biological transformations that laid the groundwork for the emergence of life on our planet. During this eon, Earth underwent profound changes, transitioning from a hot, molten state to a more stable environment conducive to the development of early life forms. Formation of the Earth. The Archean Eon began shortly after the formation of the Earth approximately 4.5 billion years ago. During this time, the planet was still in its formative stages, with intense volcanic activity, frequent asteroid impacts, and a hostile environment dominated by a thick, toxic atmosphere. Over time, as the Earth cooled, its surface began to solidify, leading to the formation of the first continents and oceans. Early atmosphere and oceans. One of the defining features of the Archean Eon was the composition of the atmosphere and oceans. The atmosphere was primarily composed of gases such as carbon dioxide, methane, ammonia, and water vapor, lacking significant amounts of free oxygen. The oceans, meanwhile, were acidic and rich in dissolved minerals, forming a primeval soup that served as the cradle for early life. Emergence of life. Although the exact timing and mechanisms of life's emergence during the Archean Eon remain uncertain, geological evidence suggests that simple forms of life, such as single-celled organisms, began to appear around 3.8 billion years ago. These early life forms, known as prokaryotes, likely thrived in the nutrient-rich environments of the oceans, feeding on organic compounds and harnessing energy from chemical reactions. Stromatolites and cyanobacteria. One of the most significant milestones in the evolution of life during the Archean Eon was the proliferation of stromatolites, layered structures formed by the growth of microbial communities. These microbial mats, composed primarily of cyanobacteria, played a crucial role in shaping Earth's environment by photosynthesizing and releasing oxygen as a byproduct. This process, known as the Great Oxygenation Event, irreversibly altered the composition of the atmosphere and paved the way for more complex forms of life. Geological activity. The Archean Eon was a period of intense geological activity, marked by widespread volcanic eruptions, mountain building, and the formation of continental crust. Large igneous provinces, such as the Barberton Greenstone Belt in South Africa and the Pilbara Craton in Australia, provide valuable insights into the geological processes that shaped the early Earth. These ancient rocks preserve evidence of ancient oceans, volcanic activity, and the interactions between the lithosphere, hydrosphere, and atmosphere. Impact events. Throughout the Archean Eon, Earth experienced frequent bombardment by asteroids and comets, leaving behind a record of impact craters on the planet's surface. These impact events not only shaped the landscape but also had significant implications for the evolution of life. Some researchers propose that the delivery of organic molecules and water from space may have contributed to the development of life on Earth, providing the necessary building blocks for early organisms. Conclusion and legacy. The Archean Eon laid the foundation for the evolution of life on Earth, marking a pivotal period in our planet's history. From the formation of the first continents and oceans to the emergence of photosynthetic organisms and the transformation of the atmosphere, the Archean Eon set the stage for the diversity of life that would follow in the ensuing eons. By studying the geological and biological processes that occurred during this time, scientists gain valuable insights into the origins of life and the evolution of our planet.